Hello again. So welcome to the next installment of looking at Python for programmers. So I think this time we're going to get to some of the meat and potatoes for what's different about Python and what you need to learn about Python. Whereas a lot of the earlier stuff is just syntactic. So let's go back to where we were in our little Jupyter notebook, so that we can see what we're doing. So we were looking at the operations we can do with these structures that Python has, and most things in Python are built around these structured data types, which are made of components of the basic data types that we've already introduced. So one of the things we might want to do in a structured operation is find out if something is in a list, a tuple, or a dictionary. So let's start with looking at something with a list. And so we've got this list here, and I want to find this tuple. So we've got 3j in both of them. So if I wanted to find out if 3j is in the list variable, and then the indentation, we can find out if it is in there. We could print the list variable, because we can print a list. So we could try running that. So we've got the in keyword, and 3j is in there, and it prints out the list in list format. And we can do the same with the tuple. We can run that, and similarly, oops, I printed the list variable. Well, I want to print the tuple variable, and here we get the tuple printed out. Now we can do something similar with the dictionary. Let's go back and do if. And now the question is, well, can we look up in a dictionary? I just called it dictionary, didn't I? So what would happen here if we look up something in the dictionary? So 0j is in the dictionary as a key, and we can print it out. But just in case you're wondering, can we do a value lookup and look up this fails because obviously it's looking in keys. Yes, you can look up values, but you have to invert the dictionary. So that is a lesson for later, and that's a much more complex operation on dictionaries. So I did say earlier I deferred looking at the for loop, and we just talked about while loops and counting. But now we've gone through the things that you can do with a control structure. We can loop through structures, and that's what the for loop is for. So we can say for item in list variable, and we can print the item. So here I went through my list, and I can print out or extract or compute with each item in our list, and the tuple is the same. It works exactly the same way, but it's just not mutable. In other words, we can't assign to it, but we could go through the list. So what happens if we want to do something similar with a dictionary? So we could go for the element of the dictionary in the dictionary, and well, let's see what we've got. And let's print the element, and we get some element in the dictionary, and we've got the key. So we could print the element, and we could print the type of the element if we wanted to know what type it was. So it's gone through and it's extracted the key. So it's looped through the thing and got the key, but we could print the dictionary. So basically has allowed us to loop through all entries in the dictionary. So it's looping through the keys. So this goes through all keys in the dictionary, and that allows us to sequence through the dictionary in the same way that this loop does. But I hear you calling out in the background, hey, wait a minute, there must be, there are other things we can do with for loops in other languages. Are we stuck with that while loop? Well, there is a kind of structure that I haven't talked about, which is a range, which is basically a lazy evaluated tuple. So I could have a range of 5, and which contains the elements 0 to 5. You see, if I print a range of 5, it just says it's a range. I could print the type of the range of 5. That's interesting. It doesn't think it can do the type of the range of 5. But the main thing we can do with range is for index in range 3 print list variable index. So this is like a lazy deferred list, and that would work the same way if I replaced it by the list of 0, 1, 2. It's exactly the same. So basically I've got a lazy evaluated list, and in fact it's the same as saying a range from 0 containing 3, which is counting 0, 1, 2, so that it works on this list. And we can tell it that it's monotonically increasing, going up by 1. So we can add further ranges. Now the other question is, can we have ranges of other things? So I'm just being silly here. So can I have a range up to true and print the value? Notice we've got a 0 here. And can I have a range up to false? And I get nothing. So that kind of shows that true secretly inside is a 1, although can I then use characters for my range? Does it handle that? Excuse me, I need the colon for my loop. Let's have a go at that one. No, so notice the range is only an integer. But I can probably do a type coercion here and do something very silly. No, and it can't convert B because it's trying to convert the string to an integer. So just in case you wondered, I just put that silly stuff in. So range is a way that in other languages you would do a normal for loop, but actually it's a lazy evaluated list of integer numbers, which is a shorthand for a for loop. But most loops are looping through different structured data types. So we've talked about structured data types. Now a big thing that's done in Python is once we've got these base data types, we can basically build them up in any way you want, which is not unexpected. So you can make a list of lists. Which is basically, that is a ternary tree. I could turn it into a binary tree if I wanted to, if you're thinking computer science. And I've built a tree from lists, and I can have lists of dictionaries, and all of this is not unexpected. And I can have dictionaries containing lists, and I can have dictionaries containing dictionaries, and tuples of lists, lists of tuples. And actually this is quite a powerful data structuring mechanism, and you find lots of coding opportunities in Python to do it this way. Where in other languages you might have started switching to records, to classes, to objects. Now there are such things in Python, which we'll get to in a later episode. But what you start discovering is the structured form of basic types gives you a lot of power in Python and is a very common way of solving problems and representing information. And classes and objects actually get used in a different way to some other languages. So that's an important part of what we might do differently in Python. But these are powerful mechanisms to enable us to solve problems for a programmer if you already are thinking algorithmically as you will be as a programmer. So there's a few other things that I can add in ranges. So let me add a new cell for us. So I won't show too many examples. You can look them up in the manual, but in the ranges you can have a binary sequence, and you can also have you can have sets. So you can take a list and you can make it into a set so that you're dealing with repeating values. So those are useful things that you can do. So I can say my set is equal to the set of the of my list variable, and I can print that as a set. So sorry, we get and of course the set is the same. Notice it's using the curly brackets for the set. So a set is a dictionary with only keys, kind of. And we've already looked at character strings. Now there are some operations that you'd expect on character strings, which I think is just best for the experienced programmer to look up rather than me go through them. You can search for a string in a string, you can index a string, you can substring a string, you can make queries about strings and substrings. Just using methods as you would in other languages, so I don't need to go through that. In the same way, I'm not going through all the standard arithmetic operators, Boolean operators and binary operators, because they're pretty much the same as in all the languages you've learnt already, and you can look those up in the manual to get the hang of things. So what we haven't done, we haven't looked at defining functions, and probably that will be a new episode. So we can start looking at more advanced things. There are union types, there are classes, there are modules and functions, and that's probably something we can pick up in the next episode. Okay, so today we'll leave that there, and I hope you found that useful today.